Welcome students. Today we are going to discuss the next topic in the subject Environmental Engineering 1 Module 3. So today's topic is Coagulation, Mixing, Flocculation, Part 1. So in the earlier classes we have discussed the various methods of sedimentation. So we know what is sedimentation now. We have seen what are the different types of sedimentation. Then we have also discussed the different zones in a sedimentation tank, etc. So today we will be discussing what is coagulation and what are the various coagulants that are commonly used in the treatment of water. So before that, we have seen that there are two types of sedimentation. One is plain sedimentation and the second type is sedimentation with coagulation. So in plain sedimentation, we know that the particles that are present in water, the suspended particles that are present in water are removed by the process of keeping or detaining the water in a sedimentation tank, and these particles under the weight of under the force of gravity will settle to the bottom of the tank. However, we know that there may be particles that are very fine, or there may be light colloidal impurities that are present in water, like the clay particles, the gels, emulsions, etc., which is very difficult to be removed by the aforesaid method of plain sedimentation. So in this case, we adopt the process which we call as sedimentation with coagulation. So coagulation is actually the process wherein we will add a chemical to the water, and this chemical will react and form what we call as a floc. So this floc that is formed after the addition of coagulant to the water will attract the fine particles, that is the clay particles, emulsions, gels, or the other colloidal particles, and then as it gets attracted to these finer particles, the size of the floc will increase. So once the size increases, what happens? Normally the weight also will increase, and finally this floc will settle to the bottom of the tank under the force of gravity. So we can say that coagulation is a process of adding coagulants to water. So after adding coagulants, they will form a precipitate. So this precipitate, which is also called as the floc, will attract the finer particles and grow in size, and finally this large size particle will settle under the force of gravity. So there are various types of coagulants that are used in treatment of water. And the commonly used coagulants are alum, or we also call it aluminium sulfate, and there is the copperas or iron sulfate. So the normally used chemicals for coagulation are as given here: alum or iron salts, or it is also known as copperas. So alum is actually the most widely used type of coagulant, and the chemical formulae as given here, it is Al2SO4 thrice 18H2O. So when we add alum to water, alum will react with the bicarbonate alkalinities of water, and it will form a gelatinous precipitate of aluminium hydroxide. So this is the floc. The floc is in the form of aluminium hydroxide, and this floc will attract the finer particles and it will start growing in size. And once the size increases, what happens? Due to the weight of the floc, it will settle to the bottom of the tank. Later on, it can be removed. So one more thing that has to be noted is that the process of treating or removing the fine suspended particles in water by the addition of alum can be done only if the pH of water is in the range of 6.5 to 8.3. So it cannot be used for a wide range of pH, but there is a limit. Only for water in the having pH in the range 6.5 to 8.3, we can use the process of adding alum. So here the table below shows the dose of alum that is to be added for different types of water. So here, if the water is clear water, normally 5 milligrams per liter of alum is required, and for turbid water 85 milligrams per liter, and for average water we add normally 17 milligrams per liter of alum. So this is the dosage of alum that is used for treating water. Now coming to the advantages of alum when it is used as a coagulant. So alum is found to be very effective in treating water. and it is also comparatively cheap and it is easily available. And there is no need of skilled labor for using alum as a coagulant, and also it removes the odor, taste and color of water. And some of the disadvantages are that the sludge that is formed after adding alum to the water has to be disposed of, and it is a bit difficult to dewater it. And coming to the pH, as I told you, it can be used only for a pH which ranges between 6.5 and 8.3. So it cannot be used for a wide range of pH. And in some cases, addition of alum also leads to the cause of permanent hardness in water, and also the carbon dioxide that is released when we add alum to water might lead to corrosion of the tank. So these are the corrosion of the pipes that carry the water, and these are the disadvantages of adding alum as a coagulant. Now coming to the next type, that is copperas or iron sulfate. So it can be iron sulfate, maybe in the form of ferrous sulfate or ferric sulfate. So when it comes to ferrous sulfate, usually this is added along with lime, and here once you add ferrous sulfate, the flock that is formed will be ferric hydroxide, and this is mainly effective for pH value greater than or equal to 8.5. and again in this case the dosage to be added is similar to that of alum, and this copperas is also cheaper than alum. Now coming to the next one, that is chlorinated copperas, that is ferric sulfate along with ferric chloride. So ferric sulfate and ferric chloride, here both will be used as a coagulant in a combination, and this is also found to be very effective. And one advantage is that it can be used for a very wide range of pH, and here also we add it along with lime, and the flock that is formed as ferric hydroxide, and like I said, it can be used for a wide range of pH. So this is one major advantage of using chlorinated copperas. Now coming to the next type, that is the sodium aluminate. So sodium aluminate is another type of coagulant that is used in treatment of water. Here the flock formed is calcium or magnesium aluminate, but the disadvantage is that it is very costlier, or it is said to be 1.5 times costlier than alum. However, it causes lesser hardness than compared to alum. So these are the different types of coagulants that are commonly used in the treatment of water. Now when we compare alum and the iron salts as coagulants, we see that the iron salts will produce heavy flock, and so it can be removed easily than alum, than when we add alum. And also, since iron salts are good oxidizing agent, it can remove hydrogen sulfide and its corresponding taste and odor. So when there is hydrogen sulfide present in water, it may lead to obnoxious odor, and it may also not taste good. So when iron salts are added, it can easily oxidize the hydrogen sulfide and hence can remove the taste and odor that is present in water. And moreover, like I told, alum can be used only for a specific pH range of pH value. However, iron salts can be used for wider range of pH values. And iron salts also causes staining, and it promotes the growth of iron bacteria in the distribution system. So this is one disadvantage of using iron salts. And as we all know, iron can lead to corrosion. So iron salts will impart more corrosiveness to water compared to that of alum. And finally, handling and storing of iron salts actually requires more skill and labor, whereas no skilled supervision is required for handling alum. So this is a comparison of alum and iron salts when it is used as a coagulant. Now coming to the various constituents of a coagulation sedimentation tank. So as you see in the figure here, the coagulation sedimentation tank, there is another name for the coagulation sedimentation tank. It is also called as a clariflocculator. So clariflocculator is nothing but a sedimentation tank where even coagulation is done. And there are mainly 4 types of units that are present in a clariflocculator. They are the feeding device. So the feeding device is the device through which the coagulant is fed into the system. Then we have the mixing device, wherein the mixing of the coagulant is done. Then you have the flocculator or the flocculation tank, and finally the settling or the sedimentation tank. So we'll see each of these in detail. So coming to the, we know that coagulant is added into the system by means of the feeding device. So it may be added either in a dry form or in a solution form. So alum or any other coagulant, either it can be added in the powdered form or it can be mixed with water and added in a form of a solution. So after this is added, it has to be mixed or agitated in the mixing basin, and then the flock will be formed. So the flock which is formed in the mixing basin will then be allowed to consolidate in the flocculation tank, and then the flocculated water will be finally passed into the sedimentation tank, where the flocculated particles will settle down and then finally be removed. And then after that, the resultant water will be taken out through the outlet of the sedimentation tank for further treatment. So after sedimentation in a water treatment process, the next treatment is filtration. So the resultant water can be taken through the outlet for the filtration process. Now, coagulation and sedimentation helps in a number of ways. Firstly, it removes the turbidities, and it reduces the bacteria that is present in water, and also reduces the B. coli that is present in water. So now we will see what is a feeding device. So like I said, there are two types. One is the dry feeding device, wherein the coagulant is fed in powdered form, and then we have the wet feeding device where the coagulant is fed in the solution form. And whether you have to use a dry feeding device or a wet feeding device is decided by the following factors. Firstly, the characteristics of the coagulant and the convenience with which it can be applied. So we have to, suppose we are going to add alum. Alum is usually added in the dry feeding method. So the characteristics of the coagulant means which coagulant are we using. So if we are using alum, normally it is fed by the dry feeding method, whereas when we use copperas, it is done in the wet feeding method. So again, one more factor that on which we can decide whether we have to use it in the powdered or in solution form is the amount of coagulant that is to be added. So if the dosage of the coagulant to be added is very small, usually we do it by the wet feeding method. So if we have to use heavy dose, then normally we go for the dry feeding method. Now again, it also depends upon the cost of the coagulant and the size of the plant. So size of the plant again depends upon the quantity of water that is treated. So if only very less quantity of water is treated, normally the plant size will be lesser. So if the plant is small, usually we go for dry feeding, and it also will be cheaper. And for larger plant, we normally use the wet feeding method. So I hope it is clear, the dry feeding device and the wet feeding device. So here the figure shows a dry feeding device. So it mainly comprises of a tank with a hopper bottom. Here the coagulant is added, dry feeding I said, here the coagulant will be added in the powdered form. So that will be filled in the hopper tank, and then it is allowed to fall into the mixing basin. Like you see, there is a mixing basin at the bottom. So the powdered coagulant is added into the tank and allowed to fall into the mixing basin. And again here you can see a toothed wheel there. At the bottom of the hopper tank there is a toothed wheel. So it is the toothed wheel which will regulate the speed of, so the speed of the toothed wheel or that will regulate the amount of powder that is being added to the mixing basin. So this is a typical dry feeding device. So here next we have the wet feeding device. So here this is a wet feeding device. So here as you see in the figure, it comprises of, in this case the solution of the coagulant of required strength will be prepared. So in wet feeding device, like I told you, we are adding the coagulant in the solution form. So we will prepare a solution based on the strength required, and it is stored in a tank. So there you can see there is a constant head coagulant feeding tank at the top. So, and from there the solution will trickle down to the mixing basin. You have the mixing basin at the bottom. So from the tank above, wherein we will add the solution coagulant of required strength, this will trickle, or the solution will trickle down to the mixing basin. And here the level of the solution in the tank and the rate of flow again is adjusted by a float valve. You see a float valve there. So that is used to adjust the level of the solution that is present in the tank, as well as the rate of flow. And a conical plug arrangement you can see here. So that also will help in adjusting the level of solution that is present in the tank. So this is a typical wet feeding device. Now coming to the comparison of the two methods of feeding, that is wet feeding and dry feeding. So wet feeding generally it is costlier than the dry feeding method, and also we have seen the arrangement or the system of these feeding devices. We know that the wet feeding device is more costlier, and like I said, the dry feeding is comparatively cheaper. And wet feed is easy to control and adjust the flow of the coagulant in the case of a wet feeding device, whereas in dry feeding the controlling is a bit difficult. Then here we are again in the wet feeding device, we have an additional tank for preparing and storing the solution, whereas in the dry feeding device we only have a hopper bottom tank through which the powder is added to the mixing basin. So there is no additional unit in the case of a dry feeding device. And also in wet feeding we require extra labor, and in dry feeding extra labor is not required. So normally one example of a coagulant which is used in the wet feeding process is the copperas coagulant, and in the case of dry feeding we use the alum. So this is all about the coagulation as well as the feeding of the coagulant. So in the next class we will discuss the mixing, flocculation, etc. Thank you.